Hey there, and welcome to the first of a set of videos that I'm going to be making about rate of change in calculus. This video is going to introduce you to the idea, or reintroduce you to the idea of what rate of change is and how we're going to be using it in calculus to identify what is called an average or an instantaneous rate of change. So here, what you see on the screen, these are some kind of teachery concepts of things that we typically do in a classroom for rate of change. You're more than welcome to read them at your own leisure. Just pause the video and read them to yourselves. But I want to go ahead and get into what rate of change is, so that way we can get going on the concept. Now here, the idea, the vocabulary, rate of change, is really not a new vocabulary. Rate of change is where you compare two different quantities of things in a ratio. And first things that algebra students get introduced to as a rate of change is typically called the slope. And it's given in the form of an equation where you say y2 minus y1 over x2 minus x1. So that's a rate of change, and in Algebra 1 we would say the rate of change is constant, giving us the characteristic line of a linear function. Well, in the real world, the rate of change is not always going to be constant, and in calculus we note it as delta y over delta x, or whatever the case is, whatever variable, whatever letters that you use as an abbreviation for the given situation. So because things don't stay the same in most applications, just think about when you're driving in your car, you have to speed up and you have to slow down. Well, you can find the average rate of change in your speed from one point to another, say when you started at your house and you finished at work or school. But we know in reality there's a lot of speeding up and slowing down and stopping, so our rate of change certainly isn't constant, and it's changing over a long interval. Now, reading that next paragraph, you can read the next paragraph to yourself as far as it's just giving you some generalities on what rate of change is. Here we're going to be looking at velocity as a rate of change, because it's comparing different positions over time of an object as it moves. So here, keeping up with the same kind of notation with the difference of values, like what we saw with slope, I can say the position at one moment in time, p sub 2 minus p sub 1, divided by the corresponding time values, t sub 2 minus t sub 1. And that's how we would get the average velocity over a given interval of time. Now, we're not going to be looking at things quite as simply as you would in an Algebra 1 classroom, where you just have to look at a graph and figure out what y values are and so on. But before we move on, what I'd like everybody to do as a challenge to themselves is reading the questions. Here we are going to understand that instantaneous velocity is not something that we can we can't actually identify what a perfect instantaneous velocity is, and because it's happening at a given instant in time. And I want to know why. Can you provide a reason why you can't write an instantaneous velocity as a ratio? And so if you can't write an instantaneous velocity as a ratio, how can you at least estimate it? So take a few moments, pause the video, and answer those questions, and when you're done, hit play again, and you can check your thoughts with mine. Alright, so hopefully you've gone and given yourself some kind of reason why instantaneous velocity can't be expressed as a ratio, and it's because if it's happening at an instant in time, no time is passing. So the time interval is 0, which would give you a 0 in the denominator, and that can't work because you can't divide by 0. It would be undefined at that moment. So how can you estimate it? Even if you can't tell me exactly what it is because you can't have a 0 in the denominator, you can estimate it. Well, the way you can estimate it is that you can get very, very close to zero. You can use a very, 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 very small number that's close to zero instead of zero, like 0.1 or 0.01 or 0.000001, something that's very close to zero. It's going to approach zero. And that's how we can estimate an instantaneous velocity at a point in time. And that's kind of what this big idea down here at the bottom in bold is. Okay, so we're going to go ahead and pause here. This is going to be the end of the first video. We'll pick back up with some examples, but here we're just talking about what rate of change is and how you can find a rate of change, whether it's average or instantaneous, by kind of comparing the differences of values in a ratio. So we're going to go ahead and pause the video here and pick it up with the second video with some examples. But thanks for watching, guys, and take care.